Have you ever just stopped and thought about it? There's this incredible invisible network that powers pretty much everything we do. I mean, from sending a quick text to joining a video call with someone on the other side of the planet, it all just works. Well, today, we're going to pull back the curtain on the amazing world of telecommunications that makes it all happen.
All right, so here's what we're going to cover. First, we'll nail down what telecommunications actually is. Then, we'll look at the huge challenges engineers are up against. After that, we'll dive into the seriously clever solutions they've come up with, see how the networks themselves have evolved, and finally, wrap it all up by looking at how this technology is shaping our world.
So, first things first. It's a big word, telecommunications. What are we really talking about here? Let's break it down.
At its heart, it's actually pretty simple. It's the art and science of sending information from point A to point B. And that information can be anything, right? Your voice, a movie, this very explainer, you name it. The how is where it gets really cool, using everything from electrical pulses to radio waves and even literal beams of light.
And really, this technology is the absolute backbone of our digital lives. It's what makes your Zoom meetings possible, what lets you stream your favorite show without a hitch, and what holds together the entire sprawling thing we call the internet.
But here's the catch. Sending a perfect signal across a city, let alone an entire ocean, is ridiculously hard. Engineers are in this constant battle against the fundamental laws of physics to make our connections seamless.
And this, right here, is the question that drives the whole industry. How do you make 100% sure that the message you send is the exact same message that gets received, without it getting garbled or lost along the way?
So let's meet the three main villains in this story. First, you've got noise interference. Think of it like static on a car radio, just a bunch of random junk that messes with your signal. Then there's signal degradation, which is just a fancy way of saying the signal gets weaker and weaker the farther it has to travel. And finally, the one we've all felt, latency. That's the technical term for lag, that annoying delay.
So how in the world do you fight those villains? Well, to get around these massive problems, engineers came up with some truly ingenious solutions that make all of our modern gadgets possible.
One of the most important tricks up their sleeve is a concept called multiplexing. The best way to think about it is this. Instead of building a separate tiny road for every single car, multiplexing is like building one giant superhighway that can carry thousands of cars, trucks, and buses all at the same time. It's all about maximum efficiency.
And you can see just how elegant it is. First, all the different data streams get gathered up. Phone calls, web pages, you name it. A gadget called a multiplexer then combines them all into one big signal. That whole package gets sent down a single line. And then, at the other end, it's all perfectly unpacked back into the original streams. This is revolutionary because it lets us squeeze every last drop of performance out of our networks.
And breakthroughs like that didn't just tweak the old systems. No way. They completely revolutionized the physical networks themselves, the actual cables and wires that connect our planet.
And the leap has been just mind-boggling. We went from old-school copper telephone lines, which were great for their time but had some serious speed limits, to today's advanced fiber optic networks. We're talking about hair-thin strands of glass that transmit information as pulses of light. We're literally sending data at the speed of light, which allows for speeds and capacities that would have seemed like pure science fiction just a few decades ago.
And this revolution is still going strong. In our wireless world, the latest and greatest leap forward is the rollout of 5G, and it's completely rewriting the rules for what we can do without being plugged into a wall.
So why is 5G such a huge deal? Well, this chart explains it perfectly. It comes down to two major wins. First, way higher bandwidth, which means faster downloads and smoother streaming. But the real game changer is that incredibly low latency. The delay becomes almost non-existent, and that is what unlocks the door for futuristic things, like a surgeon controlling a robot to perform an operation from halfway across the world, all in real time, with zero lag.
Okay, so faster speeds, no lag, that's all great. But what does it all really mean for us? Let's zoom out and look at the massive impact all this tech is having on our society.
This quote really just nails it. This isn't just about a tech upgrade. It's a full-on societal transformation. It has fundamentally changed how we work, how we learn, how we connect with the people we care about, pretty much everything.
These advancements are the very foundation for technologies that are going to define our future. I mean, think about smart cities, where traffic flows perfectly because everything's connected, or self-driving cars that talk to each other to prevent accidents, even enhanced telehealth, where your doctor can see you from hundreds of miles away. all of it depends on a powerful, reliable network.
So really, the crucial thing to remember is this. Our entire modern life, from the global economy down to that funny video your friend just sent you, is built on this invisible, essential foundation of telecommunications engineering. It's the silent hero of the 21st century.
And that brings us to one final, exciting thought. As our networks get faster, smarter, and connect not just people, but billions and billions of devices, the possibilities are truly endless. It just leaves us with one big question. As we connect everything, what will we create next?